domain and range of the function f of x is 1 over x squared if x is not 0 and it is 1 if x is equal to 0. Okay. At what point or points in the domain of f is f discontinuous? So this function so defined give us elements. First determine the domain, determine the range, and then try to give us elements of the domain where you have discontinuity, if any. Alright. But if there's none, you also state that there's no point where you have discontinuity. Okay. Suppose f and g are continuous on their domains. What can you say about continuity of f composed with g? Okay, f composed with g, g composed with f. If these two compositions exist, what can you say about their continuity? Okay. This one says verify that the function h of t equal 2t minus 3t squared divided by 1 plus t to the 3 is continuous at the point x t rather equal 1. Try to show continuity of this function at the point t equal to 1. If you look at it very closely, there's something we already learned about polynomials that will guide you. So it's not a big issue, but just try to look at it and get it solved. All right. Explain. I've lost count. So to explain. Okay, why the function b of x, we define it to be tan x over the square root of 4 minus x squared is continuous at all points in its domain. So it is everywhere continuous in its domain. That's that function b. Try to explain the reason for that. So it says evaluate integral of cos to the 3x dx. This says evaluate integral of t to the power 5 divided by the square root of 1 minus 2t squared dt. And then this says compute dy by dx if y is equal to ln of e raised to the power 3x plus 1 minus 5x. You see? And this one says that I should evaluate integral of 3 ln of x plus 5 over x then dx. Try to compute that integral of 3x squared multiplied by the square root of x raised to the power 3 minus 7 and then dx. Okay, here I encourage you, let me take this, use substitution. That's all I can tell you. Once you do that appropriately, then you get the result done. It says here you should find the integral of t plus 2 divided by t squared minus 3t plus 2, then dt. Okay, if you apply partial fraction here, that will help you a lot. And that's what I can tell you. Okay, just to hear those two concepts are being tested, the ability to resolve this quotient into partial fractions, and then already how to integrate a function that is related, that is has something to do with partial fractions. So try to use that idea. Now this is an interesting one. It says evaluate integral 3 raised to the power 5x then dx. And then this one says you should compute h prime of x if h of x is 1 minus cos hyperbolic of x, that's cos x, divided by 1 plus cos hyperbolic of x. So try to compute the derivative of this hyperbolic function. Alright. Okay, so before I go into the next problem I want to pose, let me recall an idea that we learned in class, that is the idea of how to find relative minimum and relative maximum of a given function. So I'll just recall that quickly and then I pose the next problem. Alright.